So people got really mad about this. Right, can I make fire in space work? Fire typically needs 3 things: fuel, oxygen, and heat. You've probably seen those 3 things whacked on a triangle with some flames in the middle to get that point across. Fire is basically just a chemical reaction, turning that fuel and oxygen into carbon dioxide and water. You do have to input some heat to get the reaction going, but you'll get quite a bit of heat out as well. Note that is a simplification of the process. It's not just 2 in, 2 out. There's a ton of intermediate substances made between that start and end point. Flames are a result of oxidation, the chemical process by which a substance loses electrons, in this case the fuel. This process is caused by an oxidizing agent, which can be oxygen, but isn't always. Other gases such as fluorine and chlorine can act as oxidizers, and it is possible for flames to exist without oxygen. By the definition of the words, fire means oxygen, flame doesn't necessarily. So back a step. Why is fire in space seemingly a no-no? Well, 2/3 of our fire triangle appear to be non-starters. Empty space is very cold, just under 3 Kelvin, approximately minus 270 degrees Celsius or something dumb in Fahrenheit. And space doesn't have oxygen, or anything much at all. So if we're going to make this work, we might need to
get creative!
So let's just check what actually happened in the Acolyte. There's a spike on a pressure gauge, then some sort of pipe bursts. Gas starts being pumped out of that hole in the pipe, and then yellow/orange flames appear on the surface of the ship, not immediately next to the gas leak. So from these parameters, we need to find our 3 things needed for flames: fuel, oxidizing agent, and heat. I'll start with fuel because it's the easiest. It's likely something on the surface of the ship, considering that's where the flames are coming from. What specifically? Well, something that produces yellowy orange flames. There's lots of options. Different substances, specifically metal ions, produce different coloured flames. For example, sodium ions produce yellow flames, whereas copper ions produce green/blue flames. When it comes to the oxidizing agent, that's likely what's coming from the burst pipe. The flames only appear once the leak starts, and it's likely the gas coming into contact with something on the ship's exterior is what creates the flames. Now then, heat. As I've said, the temperature of empty space is about 2.7 Kelvin, or roughly minus 270 degrees Celsius. That is the temperature of cosmic microwave background radiation, the remnants of the Big Bang that is in all of space from every direction. However, when in the vicinity of stars and other bodies in space, the temperature will be higher due to their energy output. For example, the temperature just outside the International Space Station varies between roughly minus 150 and 120 degrees Celsius, depending on whether or not it's in direct sunlight. So, we fixed it?
Wow!
It doesn't really look like we're in direct sunlight in this scene, and 120 degrees isn't really hot enough for conventional fire. What now? Is it screwed? I suppose I've got options to make this work. Either 1, we make space hotter, or 2, we make the flames colder. So how do we make the universe hotter? Just go back in time. That 3 Kelvin temperature of the CMBR, that's the temperature now. Over time, as the universe expands, it gets colder, and the CMBR is the coldest it's ever been. For a sense of scale, it's been theorised that the CMBR may have had a habitable temperature of between 0 and 100 degrees Celsius somewhere around 10 to 17 million years after the Big Bang. And Star Wars was set a long time ago. Look, I'm just guessing here, but messing around with the temperature of the universe feels like it may screw up a few other things. So assuming the universe was too much hotter might be a stretch. So it looks like we're going to have to look for some colder flames instead. So I had a few ideas, mostly bad. Some probably got me on some government watch lists because I was looking up how to set things on fire easily. But I'm going to run through some of those ideas that I found. Well, come on, they're literally called cool flames. Cool flames are somewhat what the name suggests, flames with a lower ignition temperature. However, they're not that straightforward. They require very specific conditions to form, and are often best observed in low gravity conditions like those in the ISS. But I'm going to cut to the chase and rule cool flames out. First of all, cool flames are considered cool because they ignite at under 400 degrees Celsius, so cool is a relative term here. The lowest temperature cool flames ignite at is still in the low 200 degrees Celsius. Secondly, cool flames give out less energy than regular flames, therefore not very bright. So cool flames are a no. I'm probably going to avoid saying the full name of what I'm on about here, but if you know, you know. But there is a form of the chemical element phosphorus that ignites at around 30 degrees Celsius but burns over 800 degrees. These properties are why the substance in question has often been used in munitions, but it's also why use in munitions is strictly controlled under international law. Also, that's definitely not what's going on here. There'd be a lot more white smoke if that was the substance being used to create these flames. This was one of those weird little quick ideas that I had. alkali metals, lithium, sodium, potassium, rubidium, cesium, and francium, react violently to water. The further down the periodic table you go, the more violent the reaction. The first three you may have seen in science lessons in school, whereas rubidium and cesium you can find videos of the reactions. Francium you can't find on its own. In nature it's far too reactive. But I quickly ruled them all out because the less reactive ones all have the wrong colour flames, and the more reactive ones were less flamey and more explodey. We're talking rocket fuel now. Hypergolic propellants come in two parts, a fuel and an oxidizer that when they come into contact at room temperature, spontaneously combust. Because of this, hypergolic propellants can be used without an ignition system. The chemicals are stored as liquids at room temperature and can be reliably and repeatedly ignited pretty easily. However, the handling of the chemicals can be very tricky due to their toxicity and corrosiveness. There are all sorts of fuel oxidizer pairs, but an example of a commonly used pair is dinitrogen tetroxide and hydrazine, which when combined produce flames that don't look too dissimilar to the ones that we see in the Acolyte. And guess what? Due to their properties, hypergolic propellants are specifically very useful in spacecraft. Wait, did I solve it? Genuinely wasn't expecting that when I started this.
Guys, listen to me. This is a win for us. This is a win. Unbelievable.
Look, now, I'm not claiming that that was the intent of the writers for that to be hypergolic propellant causing the flames, or that hypergolic propellant would definitely cause a fire in that exact scenario. It is sci-fi after all, logic doesn't always apply. What I'm mostly saying is that the idea that you can't have fire in space isn't as black and white as you think it might be at first. And the fact that this is sci-fi opens up possibilities beyond our current understanding of science. Take dioxygen difluoride, an oxidizer that can oxidize most fuels, and some at temperatures below minus 100 degrees Celsius. I stumbled across this compound while researching this video, but ruled it out in my main answers because we currently don't have any actual real-life use for it. But sci-fi can open up ideas within its stories for a compound like this to become useful in some way. But when it comes down to it, the most important question to answer is, does this really affect the plot? And I would pretty confidently say no. People may argue that it would ruin their immersion for there to be scientific inaccuracies, but if this ruins your immersion, I would question whether you were truly immersed in the story in the first place. And if it comes down to it, I will just invoke an act of God within the Star Wars universe to make this work, and by that I mean this exact quote from George Lucas.